Today we will discuss about the glacial processes and the topographic features, that is the glacial landforms produced or formed by the glacial activity. Now, whenever we heard the term glacier or glacial activity, the first thing came into our mind is ice or snow. So if we try to find the origin of the term glacier, the term glacier comes from the French word glace, which means ice. So from that French word, the English term glacier come into the scenario. Now, a glacier means that it is simply an existence of year-round ice. So over the landscape, so there is a continuous ice cover, and that particular body of ice will move towards downslope areas under the action of gravity. So the environment, that means glacial environment, are characterized by the dominance of ice activity as a geological agent. Now, accumulation of ice occurs basically due to the low temperature, where temperature is below 0 degrees centigrade, and there is ample amount of water vapor in the atmosphere. So when the atmosphere reaches below 0 degrees centigrade and condensation occurs, then from the atmosphere snow precipitates. Now there is a continuous balance between this precipitation of snow or precipitation of ice and some amount of snow or ice also melts or evaporates. So in one side there is accumulation, in other side there was melting or evaporation, that means other side loss of ice crystals. So an area which has continuous ice cover, that means there must be a positive balance between the rate of accumulation of ice or snow and the rate of uh, melting or rate of loss of that particular ice or snow. So always rate of accumulation must be higher. Now suppose in an area during some time of the year, that area suffers snowfall. So can we say that those areas that they are it is a glacial environment or the area suffers glacial activity? No, because it's a occasional or rare phenomena happened in that place. So to call an area or a landscape a glacial landscape or glacial environment, it must be covered by glacial ice throughout the entire year. So occasional coverage of ice in an area does not considered at all within the glacial environment. Now there are two broad types of glacier found in Earth. The first one is continental glacier, which covers the flat land areas, the land masses, that is the plateaus. And the second type is the alpine type. Basically, these are the mountain glaciers which occurs in the high hills or high altitude mountains, such as the Himalayas. Now, the entire frozen mass of Earth is known as cryosphere. So, cryosphere includes both the ice mass or snow covered in the high hill mountains, as well as snow found in lakes, in rivers, in atmosphere also, the ice crystals, as well as the ice masses floating on the large oceans near the Arctic or Antarctic poles. So all the frozen mass of water situated within continental landmass or in the ocean body as a floating landmass, they are fall under cryosphere. Now, glacial environment is not widespread at present. If we try to look at the how much area of the earth is covered with glacial ice, it is only about 10% of the total landmass of earth at present day is covered with ice, and about 60% of the world's freshwater are stored presently in the glacier. But although the present day earth only covers a very minute uh, land surface, but it was not constant through time. Glacial activity or the coverage of Earth's surface with glacial ice, it varies time to time. Such as in the Pleistocene time, the Earth was covered by 32% with ice or with snow. So the activity of glacier is more pronounced or more aerial coverage was there during the Pleistocene time by these glaciers, whereas present day it was far less compared to Pleistocene. Now, why we study glacier? Why it becomes a very important geological agent which produces lots of landforms? Not only that, glaciers activity. If we continue monitor the activity of glacier, it also indicate us about the climatic changes. Say for example, if you look at the position of Gangotri Glacier, it, so this portion, if you look at these lines, these are the glacial lines. This is the last recorded line in 2001, the position of Gangotri Glacier. So up to this blue line portion, this area is covered with continuous ice cover. Now, if you look at the successive lines, you will see that successive older edges up to which there was Gangotri Glacier. So in 1780s, Gangotri Glacier was up to this level. In 1956, Gangotri Glacier was up to this level. And as time passes, you can see that Gangotri Glacier is receding. That means the line up to which the lower limit of glacier extends, that will recedes, that will moves further upslope. That means more and more ice mass of Gangotri Glacier is melted, is lost in every year, and this signifies that a climatic changes occurs. That means particularly climate gradually becomes warmer and warmer. If the opposite thing happens in some geological time, then this type of glacier will proceeds more towards downslope areas. So proceeding towards downslope areas of any glacier indicates global cooling, whereas receding of glacial permanent glacier cover towards upslope is indicating a global warming is happening. Now, how do glaciers form? So gradually from firm to solid ice, this changeover will happen. And you can see in this picture that the first form snow, which is um, somehow looks like a star, more surface area, much fluffy, lower in density. That is the first form snow. You can see the density about 0.05 grams per cc. With successive increase in compressive pressure and density, it forms like these round shaped ice crystals, grainy ice, which is firm. about 0.4 to 0.8 gram cc, and ultimately the ice, which is the most densest form, that is zero point 0.8 to 0.9 grams per cc density. And not only this, with successive increase in compressing pressure, that is the overburden pressure, the texture is also changed. So from the initial small size ice crystals, it becomes recrystallized and form these large size crystals with well developed crystal faces. So in this way, from the water vapor in the atmosphere, gradually with decrease in temperature, snowflakes precipitated, and from that snowflakes with increase of overburden pressure, ice crystals or ice formed. Now, glaciers form where the snowfall, that means the precipitation, exceeds the melting or the loss of glacial ice mass. Now, all the processes by which a glacier gains ice, a glacier receives ice, is called accumulation, whereas all the processes by which there is loss of glacial ice mass, that can be evaporation, that can be melting, that can be breakage of glacial ice mass from the main body, such as occurred in the polar ice which is floated over the large seas, that is the icebergs. So in all this way, glacial ice mass loss happened from the main glacial body, and together these all processes is known as ablation. So there should be a balance between these two processes, between the process accumulation by which glacier accumulate, and at the other hand the process ablation. Now in this picture you can see that in this mountainous terrain, in higher altitude, as we know that with altitude temperature decrease, so if there is sufficient or suitable condition occurred in the atmosphere, then in the higher altitude areas, in the mountain tops, the accumulation of glacier happened. That means the precipitation of ice or precipitation of snow occurred. So this portion where there is continuous precipitation occurred, this portion is known as zone of accumulation. Whereas in the downslope areas, from where the loss of glacier in terms of melting, in terms of um, evaporation, or in case of polar ice masses where they are floating on the seas, breakage of those ice masses and form icebergs. So at these portions, the loss of glacial ice mass occurred. So this is known as zone of ablation. Now the line demarcating the line separating the zone of accumulation and zone of ablation is known as the equilibrium line. Now for an area to have glacier cover year around, in those areas, zone of accumulation, that means the rate of accumulation of snow, must be higher than the rate of ablation. So there should be always a positive budget. That means accumulation should be higher than ablation. If the budget is negative, that means accumulation is less than ablation, then there will be more loss of glacial ice mass. So glacial ice mass will recede towards the upslope areas. So you can have an idea what happens during seasonal variation. So during winter time, when throughout the entire area the temperature becomes lower, so there will be more accumulation than ablation. So glacial proceeds more towards the downslope areas. That means equilibrium line will be shifted more towards lower altitude, more towards downslope areas. In contrast, during summer, when the regional temperature is comparatively high with respect to the winter season, then the rate of ablation will increase from the rate of accumulation. So the equilibrium line proceeds towards the uphill portions. That means the equilibrium line recedes. So in this way, during the entire year, during different seasons, at some times equilibrium line moves towards downslope, in other times equilibrium line moves towards upslopes. So there is a continuous change between of the equilibrium line depending on the seasonal variation. The same thing happened if you consider the geological ages. In geological time span, it also happened that the activity of glacier will be more pronounced depending on the global temperature. That means depending on when there is global cooling, then the activity of glacier is more pronounced. So more and more surface area of the earth is covered with ice, such that in what happened during Pleistocene time, whereas during some certain geological time when the more global temperature of the earth was much higher, then there will be more ablation of glacier occurs. That means the lesser amount of surface area of the earth is covered with snow or ice, such as the present day situation. Now, an area which suffered or which have permanent ice masses, whatever may be the season, whatever may be the weather condition, the lowest limit of that permanent ice mass is known as snow line. So you can have an idea, above this snow line there was permanent ice cover, whatever may be the season. So the permanent snow line is always the equilibrium line during summertime, because if suppose this is your equilibrium line during winter time, so in winter the accumulation zone extends up to this level, and below this zone of ablation. Now during summer, ablation starts, that is loss of glacial ice mass starts far uh, in the upslope areas. So this equilibrium line recedes towards the top of mountains, towards the upslope areas. So equilibrium line during summer will be like this. Now this is the line, the equilibrium line during summer, above which you will find ice in summertime also as well as in winter time also. So that is why the equilibrium line during summer is known as the snow line, above which there was permanent snow cover exist. Now the glacial, as I already told you, that glacial is not a static body. The glacial ice mass is always moving through the downslope areas under the action of gravity. Now, if you look at a glacial ice mass, we can distinguish this by two zones, the lower zone, this lower zone, and the upper zone. Now, ice in this lower zone, they suffer constantly an overburden pressure. So due to this overburden pressure, the contact surface between two ice crystals, they suffered pressure melting. So the contact areas ices, they starts melting and forms thin films of water along the contact surfaces. Now, as with increasing pressure, the ice crystals are more close to the melting point. So melting will be more as we move more towards the surface to the bottommost area of a ice mass. Now, with increasing melting, that means there will be more amount of uh, water along the surfaces or along the contact surfaces of ice crystals. This water acts as a gliding agent, acts as a mobile mobile. So the ice crystals, due to the presence of this melting water along the surfaces, they glide past each other. And you can see that at the bottommost point, the gliding is more, whereas as we move towards the upper part of the glacial ice mass, due to lower amount of overburden pressure, the pressure melting of ice crystal along the surface will be less, so gliding is less. So in this way, there is a difference in movement, difference in this gliding of ice crystals in the lowermost portion and in the uppermost portion. So the glacial ice mass, they cannot cope up with this differential movement at different levels of the ice mass. So for that, the lowermost portion act as a ductile manner, and they move more easily in this bottom portion towards the downslope areas, whereas the uppermost portion, that is the upper zone, they behave as a brittle substance. So as the glacial ice mass cannot cope up with this differential movement, so in the upper zone there appear some sharp vertical cracks or breaks, which are known as crevasses, and this is the evidence of permanent distortion happened due to the differential movement happened in the entire ice mass. So some layers move faster or slower with respect to other. Due to this differential movement, these kinds of vertical cracks is found to occur within the glacial outmass. And by this way, glacial moves towards the downslope areas along with the formation of these sharp, narrow uh, cracks, which are known as crevasses. Now, if we look at the different types of glacier, the classification of glacier is actually very difficult task, and people classify glacier on various bases, among which one famous geomorphologist, Arthur Holmes, in the year 1965, he recognized three basic types of glaciers depending on the topography above which these glaciers or ice bodies occurs. The first type is known as valley glaciers. Now, valley glaciers are ice masses which confined within the mountain valleys, and these valleys are separated by the high altitude portions of the mountains from adjacent ones. So when the ice masses are restricted into some narrow channels within or between two adjacent mountain bodies, between the valleys, then they are known as valley glaciers. But in downslope areas, when these valleys reach a relatively these valley glaciers reach a relatively flattish portion, then successive valley glaciers meet with each other and they form a continuous apron of glacial ice mass. This type of glacier is known as Piedmont Glacier. It looks like a blanket of ice covered an entire relatively flat area. And the third type of glacier recognized by Arthur Holmes is the ice sheets or ice caps. Ice sheets are huge masses of ice spreading over large continental or plateau areas. These kinds of large masses generally occur where the snow line is rather low. As you can see that this is almost a flat terrain with very minute undulations. So there is no almost no high altitude hills, almost like a plateau. Now, if this entire area is covered with snow, that indicates that snow line must be far low, far below, so that this entire area is resulted with accumulation of snow. Now, if an area of ice sheet is greater than 50,000 square kilometer, then it is known as ice sheet. But if the areal coverage is less than 50,000 square kilometer, then it is known as ice caps. So depending on the areal coverage, if it is greater than 50,000 square kilometer, it named as ice sheet. If less than 50,000 square kilometer, it named as ice caps. Another type of ice found in association with ice sheets, which is known as ice shelves. These are ice sheets which extended over the sea also. That is a continental ice sheet which also extended over the water body of sea, and therefore the ice mass is floating on the seawater. So this floating ice mass over the seawater is known as ice shelves. Now, in the polar region, particularly where ice sheets are found, there it is often found that within these flat plateau areas covered with ice, there are some isolated high hill portion, high altitude portion, which remains bare, which remains naked. That means those high altitude areas are not covered with ice masses. These bared high altitude areas, these bared hills or mountains, are known as nunataks. The previous classification was based on the morphology, or you may say the areal extent in which the ice masses are found. Another classification of glacier was done depending on the thermal regime, and depending on thermal regime, there will be two types of glacier found in nature. The first one is known as cold based glacier, and the other type is known as warm based glacier or warm glacier. Now, warm glaciers, or in warm glaciers, uh, temperature is very close to the pressure melting point. The meltwater is present in sufficient quantities, and a layer of meltwater is present at the base of the glacier. And because of this presence of this meltwater at the base, the warm glacier moves faster compared to cold glacier. So because of this presence of water at the base, these glaciers are also known as wet base glacier. So basically warm based glacier are the same, but above which there is a sufficient amount of overburden pressure. So due to this overburden pressure, the bottom portion of this mass is more close to pressure melting point. That means the bottom portion of the ice, they melted due to the overburden pressure. So within an entire ice mass, there will be two different types. The lowermost portion, which have higher amount of overburden pressure, that melts due to the increased amount of pressure. So water A thin film of water forms within that uh, area, and ice glide past um, each other. So that is why they are known as warm-based glacier or wet-based glacier, as there is sufficient amount of water presence in the contact surface among the ice crystals. In contrast, the other types is known as cold-based glacier. Here, the temperature is rather low and it is far below the pressure melting point. That means here the overburden pressure is very negligible. So always the ice crystal remain as it is. There will be no melting and no formation of water at the interfaces between the two ice crystals. So the movement of this type of glacier lacks any gliding event because of the absence of water. That means that there will be almost no movement or very insignificant amount of movement, and this type of glaciers are also known as dry base glacier because of the absence of water. So depending on this thermal regime, these two types of glacier are found in nature. Now coming to the erosional processes done by glacier, as we can see that the mainly the glacial activity is found in the high altitude areas, and if we consider latitudinally, the activity of glacier is found in the near the poles, near the polar regions. So the most of the glacial erosional process is done when the glacial ice mass moves towards downslope under the action of gravity. So the activity, erosional activity of glacier mostly found in the high hill mountains. Now, glacial erosion is achieved by three main processes. The first one is glacial abrasion, second is fracturing or pressure removal, fracturing by pressure removal, and the third one is freeze and thaw process. Erosion of erosion by glaciers is depending on some factors. Firstly, erosion depends on the amount of ice mass present over an area and the speed of the ice mass by which it will move towards downslope areas. Now, as we know that the density of glacier, density of ice is higher compared to the water, and here density means it is not alone the ice crystals, but along with the ice crystals, all other fragmented materials are there. So together, all they have higher densities compared to the water or wind, and due to this higher density, due to this higher amount of mass, they are more effective for erosion to occur compared to river or compared to wind. And whenever, depending on the volume, their rate of erosion also changes. Same for the speed. Depending on speed, the rate of erosion also varies. Glacier erodes slightly more effectively than water, as I told you. The main two way by which glacial erosion was occurred, the first one is plucking, that is selective removal of a part of the rock or any particular mineral from the host rock or from the country rock over which the glacial moves. This is selectively removing particular portion of the rock mass. And the third type is and the second type is abrasion, in which there is a continuous scratching of the host rock by some tools. And the interesting thing is Here, the tools are not the glacial ice crystals, but the tools used for scratching is the already eroded sediments moving through the or moving within the glacial ice mass. So the rock fragments present within the moving ice mass, they are used as tools for scratching the country rocks. And this process is known as abrasion. Now, when the abrasion process is done by finer grained sediments, fine sized sediments, then with pronounced scratching, there are lots of striation marks, and the rock surface it looks like it is polished, uh, such that what the carpenters did after they cut a piece of wood fragment, and after that they will rub or they will polish it by the sandpapers. So similar type with the fine sediments within the glacial ice mass, if they will pass for a prolonged time over an area, then the rock surface will be polished. Continental glaciers remove soil, plants, and small hills often. Alpine glaciers, that is the mountain glaciers, they change the initial V-shaped valley formed by the fluvial activity from the river into an U shape. So glacial always use an pre-existing valley, and with time they modify it, so that you can see in this picture also. Here it is a flowage of river water in this V-shaped valley, and when it is occupied by the glacial ice mass, this shape of the valley from the V shape it changes to U shape. So that is a fundamental difference between a glacial valley and a fluvial valley. The fluvial valley will be always V in shape, whereas a glacial valley is of U shaped. Now coming to the various features or various landforms formed by the glacial erosional processes. The first is known as glacial striations. These are the marks, longitudinal, narrow to wide depressions, scratching marks formed by the moving tools, that is the rock fragments or sediments carried by the glacial ice mass. When those sediments are moving over the bedrock or moving over the host rock, due to the presence of uh, overburden pressure of the glacial ice mass, they continuously stretch and form these kinds of linear depressions within the host rocks, and the rocks then becomes striated, polished, or even grooved. Now whether the country rocks is striated or and polished such as this figure, or whether the country rock is grooved such as in this figure, is dependent on the size of the rock fragment carried by the glacial ice mass. If it is a large size sediment such that the size of gravel size, then with continuous dragging over the bedrock or over the host rock, it forms such kinds of long, straight, continuous depressions. These are called grooves. Whereas that is there of seal to sand size particles with continuous uh, abrasion over the host rock, they produce these kinds of finely scratch marks, fine striated marks, and the bedrock looks it is polished. So striations are finely cut, whereas large size striations with these kinds of large depressions, these kinds of grooves, they are formed due to larger size of the rock fragments moving within the glacial ice mass. Now, by observing these kinds of striations marks or groove marks, you can always sense, always get an idea about the direction of movement of the glacial ice mass. That means these striations marks or these groove marks will always form parallel to the moving direction of the glacial outmass. Another important thing or another important um, information you get from observing these kinds of striation marks, that whenever you are able to observe these kinds of striation marks or groove marks formed by the glacial abrasion process, that means that this area was previously under the glacial activity, and previously this area was covered by glacial ice mass. But due to temperature change, due to temperature increase, this area is now becomes bared. That means there was recession of glacial ice mass happened due to climatic changes. So if these kinds of striations are visible today, that indicate that there must be glacial activity in some ancient time, and due to climatic changes they are now exposed in front of you. Now the factors which affect the rate of glacial abrasion, first is the amount of rock debris. As I already told you that the amount of sediments carried within the glacial outmass, that is the rock fragments or rock debris, their amount, they are the basic tools. These rock debris or rock fragments, they are the tools by which glacial abrasion was mainly done. So depending on their amount, the rate of abrasion will also depend. So more and more rock debris, more and more rock fragment within the glacial ice mass, that means there will be more and more amount of abrasion going on. So increase in amount of rock debris, there will be increased amount of abrasion, increased amount of striations mark found, increased amount of groove marks will occur. Whereas a pure glacial ice, that means lesser amount of rock debris within the glacial ice mass, there will be less amount of abrasion going on. Secondly, the speed of the glacier. The faster the glacier moves, an area over which the glacier moves, that area suffers or that area evidences more and more rock debris passing over that area within a considerable amount of time. So suppose you're considering a 1 square meter area and you are considering 1 year of time. So if the glacial uh, moves faster over this area, so that means during this 1 year time interval, that 1 square meter area will suffer more rock debris to pass over it, because the speed is very high. Whereas if the speed of the glacial ice mass over that 1 square meter area during the 1 year time is very low, that means low amount of ice mass passed over that area, that means low amount of rock debris was passed over that area. So that means speed is directly proportional to the abrasion rate. Higher amount of speed, higher speed indicates higher amount of rock debris passes over an area, over an exposed rock, that enhances more abrasion. Lower speed, lower amount of rock debris passes over an area, lower amount of abrasion. Third, the thickness of the ice. Thicker the ice causes more downward force, that is the more overburden pressure, and this increased amount of overburden pressure, because of the high thickness, it will affect the abrading process over the bedrock. So due to the overburden pressure, abrading process will be enhanced in the bedrock or in the host rock. Fourth, as the bedrock is being worn away, the abrading fragments, that means the eroded rock debris within the glacier, are also being worn. So these eroded fragments are also taken within the glacial outmass and they are carried further downslope. So a continued supply of abrading fragments will be required to uphold a similar level of erosion. So in an area, when a tool is passed over that area, and if after passing of that tool, that area did not encounter any kind of activity of abrasion due to passing of any tool, so there will be no abrasion process was there. So an abrasion process to continue, there will be continuous movement of glacial ice, along with it continuous supply of rock fragment. So that means the upslope areas must have been also eroded and must have supplied significant amount of rock debris continuously, so that an area will be abraded, that means the bedrock of an area will be abraded continuously at a constant rate. The rock fragments, the rock debris carried by the ice mass must be harder than the bedrock. You cannot, if you take an example of a wax and a piece of knife, you cannot cut the knife with the help of wax, because wax is much softer than knife. But you can cut wax with the help of knife, because knife is much harder than wax. So it is the factor hardness which affect whether abrasion will act over the exposed bedrock or not. If the carried particles along with the ice mass will be softer compared to the bedrock, then there will be no abrasion, whatever may be the amount of rock debris is there. So to erosion or to abrasion to occur over an exposed bedrock, the eroded rock particles, that means the rock debris, must be harder than the bedrock. And lastly, the shape of the fragments. If the shape of the fragments is well rounded like a ball, then there will be lesser amount of abrasion, whereas an angular fragments with different angles, they have more chance, or they have more ability to scratch and scour more effectively the bedrock compared to a rounded fragmented grain. So these are the factors which affect the rate of glacial abrasion. Now, there are other landforms are also found in the glacial environment, among which the first or readily found feature is known as shards. These are typically a half bowl shaped or a spoon shaped depressions found in the mountainous portions, and they are of various size, they are of various forms. They are often known as armchair shaped, with their upslope portions slightly steeper. Here you can see this upslope portion is steeper, whereas downslope portion is relatively more gentle. And these are the places from where glacial ice mass is supplied to the valley glaciers. And these depressions, half bowl shaped or spoon shaped or armchair shaped depressions, are known as shards. Now, During the time of higher temperature, when meltwater trapped within these depressions, within this shark, they formed a high altitude lake. And is, as you can see, this shark is basically a depressed, a bowel, where the main uh, depression is at the center. Although the steepest portion is in the upslope area, but in the downslope area, that is also uh, inclined towards the center of the depression, as you can see in this case. So this is a cross-sectional profile of a shark. So the upslope area, it is steeper, highly inclined, and it has inclination towards the central part of the shark. As well as the downslope areas, it is also inclined, or it also have inclination towards the central portion of the shark. So due to this, during the increased amount of temperature, if this glacial ice mass was able to melt, so there forms a local lake having the uh, glacial melted water. These high altitude lakes are known as tarn, or often they are known as tarn lake. Now, apart from sharks, when successive valley glaciers are divided by some narrow ridge of rock masses, then this narrow ridge of rock mass is known as arid. And here you can see these arids, these are narrow ridge, and on the two sides of these arid, there will be two valleys where valley glaciers are found. Now, along this narrow ridge or along this arid, there are some places of low points of depressions along which there was constant pass between the valley glaciers. So if you can observe this arid, here you can see at this portion there was a depression compared to other portions. And this depressed portion is a pathway between the interchange of ice mass between these two successive valley glaciers. So the valley glacial ice mass in this valley, they can move within this narrow passage to this valley, as well as the valley glacier ice mass in this valley, they can also move past within this passage to this valley. So it is a narrow passage within the arid which allows interchange of ice mass between two successive valley glaciers. This narrow passage within the arid is known as cols. When successive arids meets with each other and culminate in a high triangular peak, they form this highly elevated triangular peak from where it appears that all the arids are radiated in different directions. These peaks are known as horns. As I already told you that the glacial valley is originally a U-shaped valley, which basically modifies a pre-existing valley uh, that is done by activity of running water, that is river. They modify the V-shaped valley into U-shaped. Top picture, you can also observe the clear U shape with the flat base. Now, often it is found that when the uh, within a large glacial body, some smaller glacial valley glaciers meet, then due to the increase or due to the higher amount of glacial mass in the large valley glacier, they have the higher erosional capacity, so they erode the bedrock more deeper compared to the smaller valley glaciers. Now, as these smaller valley glaciers, they have lesser amount of ice mass, so their erosional capability will be far less compared to these large valley glaciers. So when this small valley glacier meets with this large valley glacier, it forms a tributary glacier. And because of the differential erosional capacity between this main valley glacier and this tributary valley glacier, it appears that these tributary valleys, they are hanging over this main valley. So this type of feature is known as hanging valley. Now, when there was a pronounced glacial cover, mainly in near the coastal areas, so due to the glacial activity, there will be U-shaped glacier valley all along the areas where glacial cover was there. Now, during the time of recession of glacier, that means when their temperature increase, those previously formed U-shaped valleys by the glacier activity, now in this um, increased temperature situation, those valleys are now covered with ocean water or covered with river water. So these are previously glacier valleys, U-shaped valleys. Now they are covered with ocean water or fluvial water. So these are known as drowned glacier valley. So as it is originally a glacial valley, now it is drowned. Now it is submerged either by oceanic water or by river water. You can see in this picture here it is a coastal area where previously there are lots of glacial activity. The coastal areas are covered with glacial ice mass. So there are lots of U-shaped valleys you can see. But due to temperature increase, this area now becomes buried. That means there was no glacial cover. So all the marine water will encroaching through the glacial valleys, and these previously formed glacial valleys are now submerged under ocean saline water. These kinds of drowned glacial valleys is known as fjords. Another kind of erosional landform formed by glacier is known as Rosse Mountain. It is an asymmetrical hill which exposed during the path of glacial movement, and during the movement of glacial ice mass, a continuous impact in this upslope portion of the exposed hill occurs. The ice mass of this glacier will continuously impact in this surface. So there will be continuous heat of the glacial ice mass in that portion. So continuous erosion, continuous scratching, continuous scraping of this side of the exposed hill happens, and this side forms a gentle slope. In the other part, that is the downslope portion, here the glacial ice mass almost move past. So this portion did not suffer the pronounced glacial abrasion activity. Here, the main erosional process by which materials are eroded is by plucking. So, the glacial outmass moving in the downslope portion of this exposed rock, they selectively remove the rock particles or mineral particles. So, thereby, the downslope portion is little bit haphazard in shape. It is not smooth. In contrast, the upslope portion is a smooth surface. So these kinds of asymmetrical exposed rock surface having a smooth upslope smooth, gentle upslope side and a um, uneven, steepened, relatively steeper downslope side is known as Rosse Mountain. And these kinds of features are very good indicative or very good indicator of the flow direction of the glacial outmass. Now, when these kinds of Rosse mountains are of large size, that means they are more than 1,000 meter long, they are known as flyg bugs. FLYGG, sorry, flyg bugs. So whether you will call it a Rosse mountain or you call it a flying bugs, the morphology is same. That is a gentle, smooth upslope area and a uneven, slightly steeper downslope area. Uh, but the name simply depends on the size. When it is of smaller in size, smaller in dimension, it is known as Rosse mountain. When the size is about 1,000 meter long, it is known as flying bugs. So that's all. That's a brief description of the erosional processes and landforms formed by the glacial activity. In next class, we will proceed through the depositional processes and the depositional landforms formed by glacier. Thank you.